Hello everyone, welcome to the Smart Interviews YouTube channel. I'm Jan Siddham, and in this video we are going to solve the sixth question from Core Forces round number 964, which was related division 4. So the question is called as expected median, and here in this question we are given a binary of size n. In that binary array, we have our task is to using that binary array we'll take all subsequences of size k, where k is always odd, and find their median. Okay, so our task is to print the sum of all medians of subsequences of size k. Okay, in the array of size n, we need to take all subsequences of size k and calculate the sum of their medians. Okay, so this is the question given to us. Okay, now let's look at the let's look at the terms also. Binary array is nothing but array with zeros and ones. A subsequence, as we already know, is a part of the array but same order that they appear in the array, and median of the array, that is the middle element when the array is sorted. Okay, so let's look at the example. So let's look at the first example that he has given us. So we are having an array of size n equals to 4 and the value of k is 3, right? So if that is the case, for all subsequences of size 3, that is 1 0 0, the median is 0. That is, we will sort it 0 0 1, median is 0. Next 1 0 1, if we sort it 0 1 1, so the median is 1. So next 1 0 1, same 0 1 1 after sorting it, and 0 0 1. So for these two, median is 1. For these two, the median is 0. So the output of the question is 2. Like this, for every subsequence of size k, we have to find the median and we have to return sum of all such medians. Okay, so that is the question given to us. Okay, so let's try to solve this and understand how we can solve this. Okay, so first thing, when we are talking about median, so the question says that we have to take subsequences and find out the median rate. But when we are talking about finding out the median is nothing but the middle element of the array, right? Sorted form of the array. So even though you are taking the subsequence, that is, you are following the order, that is, you might take, let's take an example here. We have this example, right? 1 0 1 0 1 1 and of size k equals to 3. Let's say I am picking this array 1 0 0. You can see both zeros are after 1, but when we are trying to do median, we will sort this thing. So the subsequence we are taking is 1 0 0, but to find the median, we have to sort this thing and it becomes 0 0 1, and we'll find the median, right? We'll find the median. Okay, so so this is that why we are discussing that is, it doesn't matter what values you pick, since they are ones and zeros. All you need is count of zeros and ones. Depending upon that, you can simply calculate the median, right? If you know the count of zeros and ones in your subsequence, you don't have to sort them. All you can do is, depending upon count of zeros and ones, you can figure out if your median is 0 or if it is 1. That is one point. That is because we are having zeros and ones. Okay. Now one more thing. When we are trying to generate all medians of size k, okay, how are they formed? They are formed with zeros and ones, right? So when I'm talking about median, let's say size k equals 3, and let's say for for this string, for this particular string, my zeros count is how much? Zeros count is 2, ones count is 4. Zeros count is 2 and ones count is 4, and the value of k is 3. So can I say that for all possible substrings of size k, I can start my sequences that I'm talking about. I can start with 0 zeros, right? And if I have 0 zeros in my substring, that is 0 count in my substrings is 0, then what will be ones count? Ones count is going to be nothing but the value of k minus 0 count, right? So that is going to be the ones count. So what is the question now? The question is number of ways I can pick 0 count zeros from total number of zeros, that is 0c 0 count, and into number of ways out of total ones I can pick ones count number of ones, right? Out of the total zeros, how many ways I can pick these many zeros? Out of total ones, how many ways I can pick these ones? Okay, and if I multiply them, there are going to be these many possibilities. Okay, there are going to be these many possibilities. Now we are talking about 0 0 string. That means all we are going to have are 3 ones. So what is our median going to be? K by 2 element, right? So 0 zeros, k by 2 element. So 1 into this much will be added to our answer. Okay, 1 into this much will be added to our answer. Let's say now zeros count is 1. Okay, zeros count is 1. In here we consider all ones, right? Because zeros count was 0. Now same thing, zeros count of C, 0 count, that is number of ways I can pick 1 0 from available zeros, and number of ways I can pick ones count ones from available ones. So these are the number of ways. So what are they actually forming? They're actually forming sorted subsequences like this. They are forming subsequence whose sorted order is going to look something like this. And again, the middle element for these is 1 itself, right? So what we'll do? Answer plus equals to 1 into this. Next, one more. What is the one other next possibility? The next possibility is zeros count will be 2. There are going to be 2 zeros. So 0 C 0 count into ones C ones count. That is total number of possibilities. So what are we generating here? Here we are generating 0 0 ones. We are generating subsequence whose sorted order is going to look something like this, and the middle element is 0. So this is 0 into the number of pairs that we can, number of subsequences of size k we can generate. Okay, so like this we can count by the amount of zeros and the amount of ones in our subsequence. We can figure out how much value will be added to the total answer. That is, we can figure out what is the median and how much value they are going to be adding. Okay, so this is our solution. Now let's look at our constraints and see if we need something else. So if we look at our constraints, it says that n is 2 into 10 power 5. So here most of the time what we need is zeros count, and this is one more loop to increment zeros count from 0 1 2 and so on. right, until k, right, maximum length is k. So that would take n time. Zeros count is also n time. So n and t. Okay. So for each test case, this is going to be there. Now, what about time complexity for combination NCR? We are doing NCR, right? What about time complexity for this? NCR is n factorial by n minus r factorial, r factorial. This n factorial is going to take n time to compute. So instead of, for every value of NCR, instead of computing it again and again, what we can do is we can just pre-compute the factorial values, store them, and apply modulo accordingly. Right. And one more thing, what about division? We can use Fermat's little theorem to apply Fermat's little theorem to apply modulo over division. So we can use Fermat's little theorem to calculate the inverse modulo. That is, if anyone doesn't know, we can write this division as, we can remove this division, multiply it, and we can write it as power of inverse, and we can use Fermat's theorem, little theorem, to calculate the inverse modulo of these things. So that would be, let's call this value as a. So that would be a power m minus 2, and we'll get our values and we'll multiply it with n factorial. Okay, so that would be our logic. So this also optimizes our time. So we are only going to pre-compute it once before all test cases, and we are going to apply this logic. So this is our logic. Let's continue with the code part for this. Okay, so let's continue with the code for the sixth question. So first of all, he has given that we are given three test cases, right? So in range of end of input, so this is our loop running for t times. Then we are given two values, n comma k, the length of the list, and the subsequence length. Okay, so we'll take those also. Dot split. So if you after this, if we go through, the question also gave us the list. So list map input dot split. Okay. So this is our. So what we'll do is, as discussed, we'll declare zeros to count number of zeros. So we'll just iterate over the list and we will increment the count of zeros. If I is 0, zeros plus equals to 1. Okay, and the total number of ones will be equals to zeros, zeros minus, n minus zeros, n minus zeros will be the total number of ones. Now we declare our variable called answer equals to 0, and our 0 count in range of 0 zeros to total till we only need at max mid amount of zeros, right? So for that, what we can do is total k plus 1 by 2. So we will have at max less than half of the zeros of length of k. Okay, so in that range, what we can do is we can find out. Okay, these are the total number of zeros count. Next ones count will be k minus 0 count, right? Now total number of ways will be equals to combination of in total zeros. How can we get 0 count zeros into total ones? Sorry, combination for total ones, and we need ones count ones, and we need to apply a modulo over this So let's just apply modulo also. So instead of declaring it for every test case, mod will be declared once. So 1e9, yeah, 1e9 plus 7. Yeah, this is our mod value, and we can just add ways to this. Okay, yeah, number of ways. So this is also needs to be modulo value. So answer plus ways, and will so e answer plus ways and apply modulo over it. At last, we can simply print our answer. Now let's look at the combination function. So for combination function, first of all, yeah, let's define the combination function. Before this, we'll define it. Combination. We are given two values n comma r, that is n factorial by r factorial, and so on. So, but we'll just return if r is greater than n. We'll just return 0. Cool. So n factorial is going to be a numerator, so it is going to be factorial of n. But calculating factorial every time is going to be costly. So what we'll do is we'll declare a global factorial array. Along with that, we'll also make mod as global. Okay, and import that. So we will use that global fact and model. Okay. Now, yeah. Now let's go to the factorial. We'll declare a factorial array, and if we look at the constraints of this question, the factorial, we need at max 10 power 5, 2 into 10 power 5, right? 2 into 10 power 5 values. So all ones 2 into 10 power 5 ones. So yeah, we'll take that. So 1 for I in range 2e5, that is 2 into 10 power 5 plus 1. Yeah. So we'll get all 2 into 10 power 5 values. Next, for I in, we'll calculate the factorial also. For I in range from 1 to end of 2e5, 2 into 10 power 5 plus 1. Yeah. Factorial of I will be equals to factorial of I minus 1 into I, and we have to apply modulo over it. So yeah, let's just apply modulo over it. So yeah, this is our factorial. So this has our factorial values. Now let's go to the numerator part. Going back to this function, numerator is equals to n factorial, right? So factorial of n. Next, denominator equals to n minus r factorial into r factorial. So factorial of n minus r into factorial of r, and also will apply the modulo. So yeah, percentile mod. Now since numerator and denominator cannot be divided because they are modulo applied, let's convert denominator into inverse modulo using Fermat-Sutton theorem. So as we just discussed already, it is simply but nothing but denominator, power of denominator, and mod minus 2. And yeah, in Python, if we specify 3 parameters, it is going to compute the value with the mod in log n time. So yeah, this power function, or else we can write this power function also, but for now I'm just using this. So we got our denominator. So at last we can return numerator into denominator. Denominator is nothing but 1 by the n minus r factorial into r factorial, that is the value of the denominator, and apply modulo over this. So this is going to return us total number of combinations for n and r. So similarly, if we go down, yeah, we already computed. So this is a problem, and here just a small mistake. Yeah, COM is the form is the function name. So let's just submit it and check. So as you can see, we have successfully submitted the question. If you are interested in programming and want to become a better problem solver, you can join our 3-month-long Smart Coder course and master data structures and algorithms. Link is in the description. You can click on it to find more about the course. And if you like this video, please consider liking it and sharing it with your friends. Subscribe to our channel for more such content. That is it for today's video. Have a great day.